Okay, so let's see if I can do this for you. First thing I want to do is start with free body diagrams. So I'm going to take the large one, and I know that it has a weight, and it has a force normal, and I should call that weight 1, and a force normal 1. And then I know that there is, because that little block is here, there's some static friction in that direction between the two surfaces. And I know that the little block is pushing, making a contact force, F sub C for contact force. To the left, so I'm going to make it negative. And then that big P is pushing on the block. Then I'm going to look at the little block and do a free body for it. And so I have weight 2. I have static friction between the surfaces of the two blocks. And then I have the contact force of the big block pushing on the little block. So I'm going to say that's to the right, so it's positive. Okay. Then I said, well, I'm going to look at the large cube, and I have net F equals ma, but the only force I'm worried about is on the x-axis, because these two are going to cancel each other out. And then I have the push minus the force of contact is equal to m1a, 1. Okay. And shouldn't have done that. Let's go back up here. And then I have the small cube. So the small cube has the weight. I'm going to look on the y-axis, so net F on the y-axis for this one. Alright, and it's going to be equal to 0 because the block is not moving up or down on the y-axis. So I would say that the force normal, the force of friction, has got to be equal to W2. So I know that mu times force normal will give me the friction. So my mu, now my force normal, if this is my surface here, my force normal is F sub C is equal to my frictional force. So I know that F sub C is the same thing as m2g over mu, because here I said that the frictional force is equal to weight 2, which is m2g. So that gives me an expression for the contact force. So I'm going to take 4.0 kilograms. I'm going to multiply it by gravity, which I'm going to use 9.8. And then I'm going to divide it by mu, which is 0.71. And if I did that correctly, I got 55.2. And it's in newtons. Okay, so I'm going to come back over here. I'm going to say, well, P minus 55.2 newtons is equal to 29 kilograms, because both of them are being accelerated, times some acceleration. Well, I need an expression for my acceleration. So what I said for my acceleration was that the net force, so P is doing the accelerating, and it's going to accelerate 29 kilograms at some acceleration rate. So A is really just some part of P. So I'm going to substitute that in for my acceleration, P over 29 kilograms. Alright, so let me see, am I making any sense? And this right here, I am sorry, this should have been 25, because you're just looking at mass 1, because that's just a mass 1 there. Okay, so I'm going to get rid of that 29 by multiplying both sides by 29 kilograms. So P minus 55.2 is going to stay in parentheses. Have a P on both sides, so I need to get them together. So 29 kilograms times P minus 1600.8 Newton kilograms is equal to 25 kilograms P. So when I bring the P's together, I'm going to have 4.0 kilograms P is equal to 1600.8 Newton kilograms. Kilograms will cancel. Divide by 4 to get a value for P. And so when I did that, I got P to equal 400.2 newtons. Hope this helps.